Brilliant. So, hello everyone. My name is Philip, and I'm a project assistant at Scrap Weapons and a former international diplomacy student at SOAS University. So what I'm going to do now is give a brief overview of the series and what you can expect from today's particular event. Then I will pass over to my colleague Ai, who will talk a bit more about scrap weapons. So the goal of our In Conversation series is to create a space for open-ended discussions which help provide an insight into the arms industrial complex. So this is done by engaging a variety of actors involved in all parts of the making, selling, monitoring, and controlling of weapons, but also those who work with communities directly or indirectly affected by the arms industry. So 2 weeks ago, we had our first conversation exploring the laws and regulations governing the arms trade. And I advise our viewers today who have not yet done so to go and check it out on our YouTube channel. But today, we'll be shifting focus to the role which the very same technology that is used for destructive or military purposes can play for advancing humanitarian public goods. More specifically, we'll be looking at the opportunities within partnerships between actors in both the corporate, academic, and humanitarian communities to develop projects that alleviate the impact of war and armed conflict. So, in effect, private sector partnerships for disarmament. Today's conversation with our fantastic guests will likely springboard further questions. And whilst I have prepared some of our own to guide the discussion, we look forward to hearing from you, our audience, on those questions you have about this very multifaceted subject. So we will try to engage with everyone's input as much as we can, but even if we don't get around to all of them, remember, this is just the start of the conversation, and we hope to and look forward to engaging more with everyone in various ways, even after today. So now I'll hand over to Ai. The floor is yours.
Thank you, Philip. So greetings to everyone. My name is Aishwarya. I'm a student of linguistics at SOAS University of London and also a project assistant at Scrap Weapons. So first, I'll start off with a bit of housekeeping. This webinar is being recorded. This webinar will be published on the Scrap YouTube channel over the next couple of days. And once the speakers have given their presentations, we will open up the floor for an audience Q&A session. Please add your questions via the Q&A function. If possible, it would be great to have your name and your affiliation so that we can keep in touch, and you can start leaving questions right away. So to introduce Scrap Weapons, Scrap Weapons is the strategic concept for the removal of arms and proliferation project. It is a project that aims to reframe the debate around general and complete disarmament and is housed at the Center of International Studies and Diplomacy at SOAS University of London. Scrap Weapons sets out to challenge the dominant strategic culture of production, trade, and supply of weapons that inevitably fosters new wars, and which has a direct impact on the safety and development conditions in critical areas of the Global South. At present, Scrap Weapons is building a global constituency to request that the UN Secretariat reactivates the General Assembly's mechanism of special sessions devoted to disarmament, and includes plans to convene the long-delayed 4th special session on disarmament of the General Assembly into the new agenda for peace. In these unprecedented times, we call on states, including our governments and their representatives, to support the activation of such a 4th special session on disarmament at the United Nations General Assembly. We invite everyone, as well as your partner organizations, to support this initiative by writing to the UN Secretariat their views, priorities, and potential recommendations for a new agenda for peace, which can be sent to the interdepartmental team of the New Agenda for Peace at newagendaforpeace@un.org. You can read more about our call on Scrap Weapons website at www.scrapweapons.com and in the information pack that will be posted in the chat soon. Many thanks for your attention, and I'll now pass the floor back to Philip.
Brilliant. So I'm going to be introducing our first speaker, Martin Jebens. So I'm going to read the bio I've got here. Martin is currently working for the ICRC Weapon Contamination Unit and Delegation of Japan, where he's leading a project on how thermal sensing and AI can improve detection of weapons or can be used for other humanitarian needs. Previously, Martin worked in the field of disaster risk management. He has a strong focus on innovation, improved coordination, and planning to reduce risks. He has a background in mine action as GIS manager and drafted IMAS 07.13 on environmental management. He has been appointed to participate in several national advisory boards, including the Danish National Nuclear Emergency Group, to advise on climate change adaptation. He holds a master's in disaster risk management and a master's in volcanology, both from the University of Copenhagen. So, Martin, over to you.
Yes, thank you very much for that kind introduction, Philip. And hello to everyone. And I'm happy that you are here and will listen to our presentations in the next approximately half hour, and then followed by the Q&A session. I have prepared a few slides, which I will share with you. So here we go. Yeah, as Philip said, I'm working for the WEC unit, the Weapon Contamination Unit at ICRC. We don't ourselves actually find and remove weapons, but we advise different other organizations and national societies and countries on how they can do this. And therefore, we of course have an interest in also looking into new methods on how we can do improve the detection of weapons in general. And maybe also saying that there are many different types of weapons, of course, which you probably are aware of already. But we actually work with both landmines, other explosive remnants of war, CBRN, and nuclear weapon threats in general. So we have a pretty broad portfolio of projects. Yeah. I was a little bit unsure about how in depth I should mention these things here, but in general, when you look for a weapon contamination, either being landmines, explosive remnants of war, it is overall very time consuming, because often you don't know where the landmines or the ERWs are. It can be in any thinkable environment. You can see my background picture here on the Zoom is desert area. You see the one here, which is in a highly vegetated area. You have minefields on the Falkland Islands, or used to have, which were in a more Arctic setting. You have it in bare mountains, and you have it in all different contexts. And all of these weapons are also made of different. They have different compositions and different sizes. You find them in different depths, as you see on the other. Is that to the right here? I suppose maybe to the left for you. Some are made of plastic, some are made of metal, some are improvised explosive devices, as you're aware of. So all of this is in need of different technologies to find each specific object or each type of object. So there's no solution which fits all. You cannot just take a simple detector and go out and find everything. You will have to, we have a toolbox of tools in mine action, which you can use in different settings. And once you realize what you need to find and where, then you can open your toolbox and you can use the appropriate detection tools to find whatever you are trying to find, whether it being landmines or ERWs. In any case, it's a long process, and as you see with this deminer here, is also that you don't clear a lot of land every day. Often you will find also, of course, that you will have a sediment or a terrain type with a lot of force anomalies, because there might be a lot of metallic rocks in the soil. So you might get which we often talk about the probability of detection and the false alarm rate. And ideally, we would like the probability of detection to be very high and the false alarm rate to be very low, of course, because you have to remove both your positives and your false. Because at the end of the day, you never know whether or not a false alarm really could be a mine or not, for instance. And of course, due to this long process and the time it takes to find all this, it also takes a lot of time for civil society to return to the place they have been forced to leave, often in connection to some kind of conflict or yeah. And therefore also the sector seeks to find new and faster ways of detecting landmines and ERWs. The thing is, again, of course, that you cannot find a lot, or you cannot find everything all the time. So that puts a little bit of a demand on how you do this. But at the end of the day, this is all about risk. It's all about protection of civilians. It's about making sure and securing that civil society can move back as soon as possible after a war and conflict. But it also has to be done without compromising the safety of our clearance personnel. This is very important because they need to be safe to remove and find these objects as well. And these conflicts, of course, can take years and years, making it very difficult for civilians to return. We still have, I mean, a lot of clearance efforts going on in Cambodia, you have in Vietnam, you have even in Europe from the Second and First World War, you still find explosive remnants of war. Quite often in Belgium, you still find it in Denmark, you find it, I mean, basically everywhere, unfortunately. Even at sea, you can find a lot of sea-dumped ammunition, which is now laying on the bottom of the seafloor and slowly corroding and polluting our waters, which is actually also a UN treaty for. All of this ammunition and the weapons, of course, contamination is often has some kind of UN treaty which prohibit the use of it. So it be the CBRN, it being landmine, anti-personal mine ban convention, and so on. But it doesn't really prevent that many of these objects are still out there and really hindering the use of land and the use of fields to secure livelihood for people. And therefore, of course, we're looking into finding solution which can be conducted with a pretty low risk and cost efficient. But you also have this nowadays, of course, with climate change, that we want to make it a sustainable way of detecting these objects. So we are trying to avoid big machineries. We are trying to avoid sending a lot of people into the field. We are trying to avoid not clearing land which is not contaminated, which is something that has happened a lot in the past. And that's basically what the projects I'm also going to say a little bit about here, but also what Professor Sawada and Gurkan will mention in a while. Because that's something, of course, we can do to speed up the process of detection of landmines and explosive remnants of war. Until there's always been a lot of innovation going on in the sector, but there has been a disconnection between academia and private sector and the humanitarian sector. So we have not been very good at talking to each other, sharing knowledge, and making sure that academia and private sectors are understanding the problems we are facing as a humanitarian mine action organization, for instance. So that's one of the things. That's something which we have been doing here in this consortium between the Waseda University, NEC, and the International Red Cross. Also, we realized also in early stages that you need innovation to cope with some of these challenges. And that comes with a challenge as well, and that's the lack of funding and time. Also saying, though, that innovation doesn't have to start from scratch. So we are not inventing everything from scratch. We are actually just taking methods which has been used in other sectors and try to put them together and use them in another way. So for instance, with Waseda University, we did put thermal sensors and normal cameras and drones, took pictures of the ground and trying to use AI, artificial intelligence, to detect landmines and explosive remnants of war, much as a self-driven car would do on a street. It needs to know the difference between a child or a cat or a tree or traffic light. We are just trying to tell the difference between a mortar, a grenade, or landmine. So actually the innovation do not have to take that long time, as long as you use well-known methods in advance. Yeah. Then, of course, we need to break down silos as well. And I think also that's something we are doing here. Mine Action, for instance, also for a long time was very siloed. Now we are starting to reach out more to archaeologists. We're reaching out to computer scientists, academia, trying to really get more input on how we can do these things faster and still at a low risk, so we don't compromise the safety, both for the people detecting, but also for the civil society after. And then, of course, we need this collaboration I'm talking about. Humanitarian organizations like ourselves, we don't have the time to allocate for all of this innovation, and we definitely don't have the money for it, and we don't have the knowledge, really. We have the idea, and we can pinpoint the problems and the challenges in the field. Academia, on the other hand, they have the time and interest to do research in these things, to expand their knowledge, which we can benefit from as long as we discuss what our needs are and what the academia can offer. And then we have the private sector who has the means to actually push these things through, to aid and build what we need faster and more efficient. And I think this collaboration we have had here is quite it's actually been really successful on sharing and getting to understand the challenges and move forward on producing methods which can help finding landmines and ERWs. So you will hear about Waseda University first. We'll talk about this project we had with them on remote sensing and AI and how we could do that. And then we have had a project with NEC as well, in which we have tried to predict the position of contaminated areas using a lot of freely available data. So that data could be land use, it could be geology, it could be waterways, infrastructure, and so on. But the idea with that project was basically that we keep asking for more and better data all the time in the humanitarian world. And we discussed that maybe we actually have all the data we need already. We just don't understand it. And we don't have a platform to analyze it in. So instead of keep asking for more and better data and just getting bigger and bigger data sets, we thought, okay, let's try and see what can we actually, with the data we already have, can we predict where we can find these landmines and the explosive remnants of war. And that's what NEC has been doing. And ideally, you can say that's quite a big overview. Ideally, they would do that first, and then Waseda University, ICRC would go in with their drone and thermal cameras and then pinpoint individual landmines. Then you can say, okay, why is this then cost efficient? Yes, it is really, because we haven't done the CO2 budget, because of course it costs something CO2 wise to produce big laptops and also electricity to run them. But in general, seeing outside of that, when you go into the field, these methods will be able to cover really large distances at a high speed. You don't need to send a lot of people into the field. This type of innovation is also quite sustainable, and that's also in line with the SDGs and the Sendai framework for disaster risk reduction, which is aiming at reducing risk of man-made and natural hazards. It's pretty secure for operators because you don't have to send a lot of people into a known or unknown contaminated site. NEC can pinpoint the area where you would find a contamination, and we would then go in with a drone. It's pretty cost efficient again, only one person flying a drone, one person maybe doing some AI on it. And then AI is exceptionally good at making order in random data, which is often what we need in this sector as well, because different armies or non-state army groups will plant landmines or explosive remnants of war differently, depending on their objective in the given battle or war situation. So we can actually harmonize some of this data and make sense of it. And then these methods has been used with success in other areas. So I think that is maybe just quickly, just to show, this is, I don't know if you know that, but remote sensing is just like, in this case, a type of sensors which you have on drone or satellite, which measures some kind of energy change from the ground. And in this way, you can see different objects on the ground. I will keep it to that and give the floor to Professor Sawada and Philip first, maybe. Thank you, Philip.
Yeah, no, I just want to say thank you very much for that really comprehensive introduction. And I think you highlighted some really key points. Particularly, I liked your emphasis on how this collaboration really is possible. And I'm looking forward now to hearing more about how it looks like in practice and who really is involved with this. So yeah, thank you very much. If you want to introduce our next speaker, that'd be great.
Okay, yeah, sure. I will then give Professor Hideyuki Sawada the floor. He is a professor at the engineering faculty at Waseda University in Tokyo. And we have been collaborating on this project for 3.5 years, I suppose. So thank you.
Okay, thank you very much, Martin-san. Okay, I would like to share my slide here. Do you see the slide? Okay.
Yes, we see it.
Okay, following the talk by Martin-san, I would like to introduce our activity so far for almost about 3.5 years, as Martin-san introduced. And this is the work conducted by me and my students, of course, and the ICRC, especially Martin-san, it is a project to detect mines and landmines and unexploded ordnance and explosive remnants of war by using AI technology and drones. Okay, this shows our purpose. Okay, our purpose is the purpose of this project is to use AI technologies to detect landmines and explosive remnants of war. As you know, the number of landmines and the UXOs left by war is still increasing greatly. And in fact, before joining this project, for me, in fact, I didn't notice this. I was very surprised with the situation of this very dangerous object. And yes, I decided to join this project with ICRC. Okay, the idea is to use a drone and a thermal camera and the usual RGB camera. And by installing the cameras into the drones and to let it fly over the land, and we try to detect the object by referring to the thermal information by the thermal camera and also color information by using the RGB camera. Okay. These days, a drone and the thermal cameras is rather, inexpensive these days. I mean, it is rather low cost and easy to use. So far, we have been using these equipment for the test bed for detection of the landmines. Okay, this shows the costs. Okay, and this is the picture of the drone with the camera. We let it fly, then take pictures, and then we apply AI text for the detection of the object. Okay, the idea is like this. The principle of the detection method is like this. The thermal camera is able to detect the heat radiated or emitted from our object. What we are paying attention is the difference of the thermal emission from lands and the object made of metals or plastics and some more. Even such objects are buried not very deep, but not very deep, but some amount of the distance lower than the surface level, such object radiate or emit some heat. So we try to detect such heat information from the air. Okay, these are some pictures that we took with RGB camera and the thermal camera. These are the objects that we see. There are 3 objects like this. Then from a thermal camera, we can detect with the different thermal emission as shown this, and also these 2 objects, and also it's the different brightness. We have a possibility to detect such objects. Okay, so okay, yes, and what we need to examine is how high we can fly the drone, because if we are able to fly the drone higher, then we will see the wider range. But this means that the object to be detected can be smaller. So this means that the resolution of the object can be smaller. So we need to have a balance between the resolution of the object and also the area to be shot by the camera. So we need to examine the flying height and target size. So far we are testing the flight and the height of 2 to 3 meters up to 10 meters by changing the flight, and also taking pictures. How much resolution we'll be able to examine the data for to be given to the deep learning or AI. And okay, so far we tested this system in Japan, in our campus firstly, and secondly we tested in Denmark, and also recently Jordan. Okay. The Mati-san visited, of course, in Denmark, and he tested taking pictures in the field or in Denmark, and also he visited Jordan last year to take some pictures in the field. Okay. Yes, these are the pictures, the field, picture of a field that Mati-san made a test for flying drone and taking pictures. Okay, and so far he tested by 5 different conditions, okay, in different weather and the temperature and the wind condition, because the flying of drones maybe have some effect from the wind, and also the time in a day, because the heat, such object accept heat from the sun in daytime, then the heat is radiated or emitted. So the radiation of the heat may be different in accordance with the time. So we need to test the pictures taken in different time in a day. So the conditions that Mati-san tested so far, and yeah, by examining the different weathers, temperatures, wind conditions, and of course shooting height. Okay. Okay, and this is the yeah. Okay, these are okay. So far, the thermal images have been captured 400 number together with RGB camera to make some relation between the thermal information and the color information. Then in Waseda University, we have constructed deep learning for the learning of the object to be detected. Okay. In this system, we constructed a tiny YOLO V3 deep learning system. Okay, and yeah, these are some flaws for the learning and learning for the detection. Okay, in this system, the training time was 27 hours by using a PC with a board, processing board. So far, yeah, it was successful. Like this, the different shape of object can be differentiated with each other, like -1, -2, -3, and -4, okay, like this. And in different conditions, it works. Not perfectly, but yeah, it works like this. Yeah, in the five different environment from test 1, test 2, 3, 4, up to 5. Okay, in all conditions, the object detection works. Okay, not perfect, but works like this. And okay, then the last year, Mati-san visited Jordan, and he took pictures, thermal pictures and RGB cameras in a real field, like this. And yeah, we are on the way for examining the data. Maybe it will take some more time for processing all of them, but yeah, we are on the way. Okay, this shows the lessons learned in Jordan. With thermal sensor, we mostly like see all surface objects, okay, in the flying condition, like this. Yes, and the possible AI algorithm would detect explosive remnant of war, as I showed. And also what we are trying is to test the drone flying higher, a little bit higher, so that we will be able to get data and detect the object with a higher pace, much effectively. And also, Mati-san took pictures in a subsurface ERWs. So far we made a preliminary. We have preliminary results of thermal images. Some objects can be mistaken as rocks. So we need to modify some structure of the deep learning algorithm, because in a buried condition, the heat radiation is smaller than the case that the objects are placed on the surface. So we need to consider some lower level of the signals. And yes, I think that's all. Okay, that's all we have been working so far. Thank you very much.
Thank you.
Thank you so much, Sawada-san. That was a very excellent presentation on the implementation of the technology that we initially discussed about. And you were very right. There are a lot of geographical constraints that would affect how the data is read. And as Martin also mentioned, funding would be of the utmost importance right now so that this technology can be developed, especially since, as you said, Sawada-san, it is not in itself expensive to acquire of drones and other such similar technologies. So thank you so much, Sawada-san.
Yeah, thank you very much.
I'm going to introduce our third speaker for the day, Dr. Gurkan Solmas. Dr. Gurkan Solmas is a senior researcher at NEC Laboratories in Europe, Germany. His research interests include artificial intelligence and machine learning, IoT, and the cloud edge systems for applications to smart districts and mobility. He received his BS degree in computer engineering from Middle East Technical University in Turkey, and his MS and PhD degrees in computer science from the University of Central Florida in the USA. At NEC, he has contributed to research projects in areas such as IoT, smart districts, localization, automated driving, and humanitarian applications. Over to you, Gurkan Solmas.
Hi, everyone. Thanks very much for the... yes, I'm sharing the correct screen here. Do you see my slide?
Yes.
Oh, cool. Thanks very much for the discussions, and I also look forward to the question answer at the end. Today I will discuss the humanitarian data space, which is the proof of concept project that Martin Jebens shortly explained in his talk already. And this group is from the NEC. We also collaborate with ICRC, especially we collaborate with Martin from my ICRC. So what are we trying to achieve here is to have a humanitarian data space and make it useful for demining. How we can make it is the idea is we could maybe have all available data sources harmonized and processed through a machine learning pipeline. And this pipeline would calculate an index for demining operation. For instance, we can consider a demining priority index. Means if there is more risk on mine, we can have a more priority as an example. Or if there is more value in a certain region, we could give more priority similarly. And here the main concern is the livability of districts. So why are we doing this whole thing in the demining? Is at least a major part of it is accommodating people in these areas where there were past conflicts, as well as making it useful for other purposes such as agriculture. So we can consider here the livability of the district, and this would be important, especially for the safety risk. If we have certain areas with more possibility of mine presence, maybe those areas can be prioritized for clearance, as well as it could be also related to geographical characteristic of the areas, as well as the distance to the key facilities in the environment. And those can affect the livability of the district. So here is a illustration of the design of the system we developed during this proof of concept. On the top, you see humanitarian data sources. So you will see different components here. Due to the sake of time, I won't go detail for each of these components, but basically you might consider having a data set of data and as well as having certain knowledge from the domain. We develop a system where these data sources with different characteristics can be harmonized and can be accessed through one unique platform. And through this platform, we could develop machine learning applications. And here is an example that we did in the proof of concept. We used the Jupyter notebooks, which is very commonly used now for data scientists, for Python programming. And we had also analytics and AI implemented on this platform. And then we also have an open geographical information system platform called QGIS. We can use it for interfacing with the users, visualizing results. So shortly on the top, we might consider having many existing data sources. This can include as well drone, but also it can include any data could be from satellites, could be data that are collected from the area, from surveys and so on. And the idea is to bring them together and harmonize so that they can be easily accessible by application developers who can be data scientists in AI machine learning, who can implement data analytics on this data and visualize in the geographical system. So the first step, data harmonization, which includes preparation of data, integrating data, as well as enriching the data, meaning having a data plus additional information related to data. This additional information can be learned from external knowledge bases or could be explored in other data sets. And the data platform, as I said, is the platform that brings together all possible data sources for the demining. And the data lab is where the AI and analytics is implemented. And the solutions would also involve user. So it will include the user interface as well as the user who can interact with the system. So first we started working with data processing tools. As I said, we used as AI Workbench, very popularly used Jupyter notebooks, which gave us easy access to when we have for instance, CSV files or any data available, we could start gathering initial insights in a pretty short time before even running machine learning models. But as well, we can also run machine learning models given initial data sets. And the second part we worked was the geographical data processing and visualization using the QGIS. As I mentioned, QGIS is a geographical information system. Once we have data from maps, such as shapefile or other formats that are readable by QGIS, we could start importing those data into this system and visualizing them. Having these two on hand, we start developing AI models. And AI model is based on the data that we collect open source. So there exists various open source data related to demining. So we collected data from a certain region. And here initially we considered two possible AI model. One model is given a very large region, which is like a country, big country area. And given the ground truth data that we know in the ground truth that these areas, such as polygon areas, are having hazard. So that are already collected information or known information. And given this and the same number of other areas where we don't have a hazard, could we train an AI model that can distinguish these two areas from each other, hazard area and a non-hazard area? And given all the geographical data available and harmonized in the platform, we could train with many different features without giving much preference over one feature over another. And initial models already gave us really high accuracy for understanding hazard presence. And as said, this is from a 50% benchmark, meaning we have one area which has a hazard, the other area which doesn't have a hazard. And given this same number of samples, AI model tries to distinguish. So a random model would distinguish with the 50% accuracy. But this AI model using geographic characteristics have much more accuracy. And the second model we trained was to understand which hazard it is, because hazard could be landmine, but could be also other hazards, other explosive remnants of war, or maybe disaster-related hazard or conflict and so on. And this one had even higher accuracy because for this model, we know already that this is a hazard area. For this hazard area, we try to distinguish. And in the data set, most of the data was related to mines, although this is a general hazard data set. So it gives us from a benchmark, maybe around 90% of landmines to the 97%. So still there is some increase, means the AI model could still differentiate also to understand which type of hazard it could be. And we also checked which features would be important for understanding these characteristics. We noticed this distance to key facilities such as buildings, roads, province, and waterways could be important for the model for understanding my presence. In both scenario, we can say that. And the solution part of it, where we try to visualize this to the user, we had a heat map visualization on the QGIS, again, in the same platform, where we have all the data available. We could also visualize the raw data, but as well as the analytics result from the initial AI models that are trained. And as you see, in a given area that are marked by user, we could start creating heat maps where these yellow polygons represent hazards, known hazard areas. And as you see, model could capture some of them, but not all of them. Especially given a smaller area, the resolution is the key. When we want to have even higher resolution, the problem becomes harder. In that, we can also fail the model. For instance, if we got even smaller area. So again, the model was trained in a country level. So once we get the smaller and smaller area and test this model would start to fail. So here is the video where we show how it could be easily visualized. This on the right side, you see all the, I'm sorry. I need to restart again. On the right side, you will see the data features that are used, such as agricultural information, area size, location, districts, region, waterways, and all these features are listed on the right side. And we could also visualize from the layers using the QGIS. And here, for any point that is given for testing, we could also see probability of mine presence given by the AI model. So this way, we could easily, for anyone who has any idea on landmines or interest, can actually visualize this and ask any point and see probability of an AI mine presence. And based on this, it could be useful for understanding which areas are more keen to have hazards or mine presence. Afterwards, I mentioned that in the initial test, we trained the AI and test AI in the whole country scale. Later, we wanted to focus more on the study area, because when the resolution gets higher, so when we need to learn in a certain area, in a small region, landmine presence, then the problems become harder, because every region have also different characteristics that might be highly different from the whole country. So for this, we trained a more specialized AI, where we have tested this in 2 study areas, which we call study area 1 and study area 2, SA1 and SA2. And SA1 is chosen in a capital city of the region, which is also smaller land area, and the terrain was mainly flat, and it has higher elevation, and population density is high in this study area. The second study area is more closer to the central land, and it is far from the capital city, where it has a larger land area, and it's mainly mountainous area, and less population density. So we try to here see the difference of the same model. If it could capture both, in both study areas, it could capture the characteristic better. And in the study area 1, also there is low distance to the community facilities as expected, as it is highly dense area in terms of population. So such as roads, buildings, financial, educational facilities, airport and health sites are in the lower distance. And in the study area 2, there are larger variety of features due to terrain change and size. As I said, this area is not a threat. For that reason, elevation also changes and other geographical characteristics. In the trained AI, we also applied certain thresholds for understanding risk levels from yellow to the red. Yellow means the lowest risk for having a landmine area, and red means highest risk for having landmine area, or we can call landmine contamination. Here on the left side, you see the study area 1, and the right side, you see the study area 2. And the risk levels are given by the AI model that is evaluating the risk of landmine for given areas. And the yellow triangle, as in the previous example, is the ground truth data that we know that there were hazards or landmines in this area. And we have seen that in both study area, although they are very different in characteristic, and without even presenting any data from these study areas, the AI model could already learn from the country data set, and it could already, with high accuracy, predict the landmine present areas. And for this also we tried with different resolutions, although I don't have much time to go every resolution here. But as an example, we tried from 50 meter to 500 meter and 5,000 meter resolution to understand how it would succeed. We see in all of them, it has certain accuracy that's for sure given more than normally raw data gives. But especially for 500 meters and more, the AI model already gives a really high accuracies. That means this would be useful for understanding landmine index for either people in doing operation, or it could be for the domain experts trying to understand the region, or also could be even for people who have interest to understand more about the landmines. What would be the next steps given this initial proof of concept study? We consider here 3 possible next steps for the community, but of course there could be more than this. The first one is about establishing a data space with multiple stakeholders. I mentioned there will be a data platform where many heterogeneous data sources can be combined and harmonized. We have components that can do that semi-automatically. With a small effort, we can include a heterogeneous data set, and we can leave most of the work to the AI part. I didn't explain much on that side, but actually there is also an AI that combines the data set together. For this, we need to establish collaboration with government and non-governmental organizations, because having multiple stakeholders means we need to have people on the board. So they should be willing to share their data with the platform. This is one step that we consider would be useful for community. And otherwise, we can also work on existing open data sources. Already we mentioned in the previous talk by Martin that there exist open data sources, and they are even more than we would expect normally. So it means we can explore more open data sources and bring it to the combined data space for the landmines. The second aspect is, as a next step, could be applying this technology in a conflict region with planned or ongoing on-field operation. What Professor Sawada-san told us is that the drone usage, it can be very useful to pinpoint the landmines and understand exactly which type of landmine. But even before that, once we have geographical data available from open sources or from government or NGOs, we can already have initial landmine risk maps. And based on this risk map, we can allow domain experts or on-field people to decide their planning, do their planning for landmine cleaning operations. In this way, we can consider these domain experts actually utilizing the data space for their operations. This would be also an important next step. And lastly, I want to give the possibility to leverage multimodal data. Although we already have multimodal data, but even more of it. For instance, we could have existing drone images in the system, maybe already pre-processed by a machine learning model, such as YOLO or fine-tuned YOLO, or a model, for instance, by the Sawada-san's group. These kind of features that are given by image processing could be also useful to leverage, as well as features from satellite, could be about vegetation or other characteristic, and surveys and reports, which are mainly technical reports or non-technical surveys, where we have data collected from the people in the field or from news articles and so on. Those could be also incorporated into the data space. And as said, this would enable running missions for landmine clearance all over the world. That would be made easier as well as more efficient through having a common data space for the landmine clearance. That's it for my presentation. Thanks very much, and I will be happy to join the discussions.
Thank you so much. That was really interesting. It was really fantastic to see how AI could be used for this data processing, but even the predictability. It's a really exciting area to think about the potentials. And then going back to this role of having lots of different stakeholders and the importance there. So while we actually wait for now is the time for any participants viewing us to ask any burning questions you have. But whilst we wait for those to come through, I thought I'd get the ball rolling with kind of a bigger picture question, but linked to this idea of the stakeholders. I really wanted to know, this is a fantastic project that has come together. I really wanted to know what steps or decision-making process was needed to direct resources towards a project like this, and how could this be facilitated or fostered going forward? So for example, what actors were involved in saying, hey, let's get something like this together, let's get it off the ground? Where were these decisions coming from? What spaces were used to get this project off the ground? If anyone wanted to step in here and provide your own thoughts on that, this would be fantastic. And actually, just I thought I'd mention, because everyone did keep to their time quite well, but just as it happened, the hour flew by. So if possible for speakers to stay on a bit longer, we can happily keep the session running for maybe another 15-20 minutes over time, longer if necessary, but just so we have enough time to properly have a discussion here. But yeah, if anyone wants to jump in on that, how does something like this come together, and how can we ensure it happens going forward? Just anyone? Yeah, Martin.
Yeah, no, I mean, maybe I should say something about that as well. You can say it's partly a little bit about coincidence. So it's being open-minded to taking the opportunity and ready to grasp the opportunity. So for the work we have been doing together with Waseda University, it was actually because in general, it was acknowledged from ICRC side that we need to work with academia in order to lower the impact of humanitarian disasters. So we make from time to time agreements with universities on collaboration. So one of these collaborations or agreement was made with Waseda University, and then we were discussing after that, okay, so now we have the agreement, we want to do something together, what can that be? So that was maybe on a little bit more managing level that this was agreed, and then the weapon contamination unit, which I'm representing, we were put together with Professor Sawada and his team, and yeah, then we came up with this idea here. For the collaboration with NEC, it was actually more coincidence, because we went to Japan on several occasions, and we had these meetings with workshops out there as well, and during one of these workshops NEC was presenting, and that led to discussions with NEC Tokyo, and then the ball starting rolling, and it took quite a long time, I would say, and that's why I also mentioned in the beginning that it needs time and to build these relationships. I think I talked.
Yeah.
Did we talk Gurkan and Erno? I think we talked for maybe 1.5 years before maybe even 2 years before we made an MOU, and you understood our needs and I understood what you could deliver, and then we started working from there. So it's a time-consuming process in which you build confidence and you build trust, and you learn from each other what you can do and what they can do. You're muted, Philip. Thanks.
Sorry, I was just going to say, then from the NEC side, how do you come across something like this, and was it just a coincidence, and how did it then develop going forward?
From the NEC side, we were basically looking in all to support humanitarian aid actions. It could be, biometrical solutions for vaccines in refugee camps and in Africa, to make sure that people were only vaccinated one time. Or it was other things like fighting counterfeit medicine. And then we looked into the humanitarian aid aspect, especially on the demining side. And we started this conversation and talking with Martin and seeing how we can do it. And a lot of this 1.5 years or 2 years were spent on really figuring out what is it, what can we do, where should we focus? Should we go into the video processing part like Martin and Professor Sawada was already doing, or was it more on the bigger picture? Where can we save time and through that, multiply the effort here? A lot of discussion, a lot of understanding. But I remember that once we had set it out a target, then probably within 3-4 months, we were coming to the first really good results, which we then refined over the next 2-3 months here, which probably shows that, if you put your mind on something with experienced researcher like Gurkan, then things can be achieved. But it was also very important to have this discussion before that to understand how is the sector working, what is actually needed, where can we make gains which are not so easy to achieve if without us, and that part. So that I think was important for the overall concept.
Yeah, brilliant. And Gurkan, if you wanted to jump in there at any point, I'd also be interested to know, you mentioned demining. I think you saw it as part of a wider humanitarian support. Was there a particular reason for demining, or was it purely because it fit within that wider umbrella? Because disarmament is often underlooked in terms of its intersectionality with various other areas. So that's what I think that's what we all found quite impressive about this particular project, that it was tackling like explicitly arms related problem using this private sector technology. And why exactly demining? This is one of my questions, but Gurkan, if you want to jump in.
I think so. At the beginning, as Erno mentioned, we wanted to work on the humanitarian domain. Also, we were very motivated because of its good use for the humanity. And of course, as researchers, we wanted to take the challenges there. But also, domain expert is very important here. So because some of the things in the domain, as a researcher might be knowledgeable or might not be knowledgeable. For our case, Martin introduced us the field of landmine clearance, and there is actually a community around this. So it is one of the key humanitarian problems now in the world, to clear areas from explosive remnants of war. So this is one of the already known by many people challenge. So it wasn't really hard to focus on the landmine in that sense. But as Erno mentioned, there are other obvious challenges too in the humanitarian domain. So this would be also interesting, of course, to explore. But I think this combination of having a domain expert who has knowledge already in humanitarian problems, as well as having technical people who can maybe train AI models or work on developing a project or a software would be actually beneficial. Yeah.
Before I leave, maybe one last comment. Clearing the landmines is the important first step. But what you will see that is once the area is released and it's becoming safe again to move back, then we have an area which can be developed. And the real economic value of demining is that after a few years of being able to utilize the land, you see thriving communities, you see the use of it, you see suddenly that agriculture, but also housing has been developed in that area. And that is overall giving you an economic upturn here. And one of the questions is whether the data which we are now using for the demining could be also used for predicting how much of this economic development can be achieved and what could be, the target for the next 5 to 10 years, plus what probably need to be done as kind of investment to achieve these economic benefits here. And that is among the next challenges which we're looking into.
Yeah, no, I think it's great to have that perspective. I think that's such an important part of all of this. So that's really helpful. I don't know if Hideyuki, you wanted to jump in there. My colleague I is a bit.
Yes, thank you very much. Yes, I greatly agree with the Erno's opinion. Yeah, the development, the development for the of course, agriculture and the housing is important. So yes, well, from the viewpoint of the academia, what I'm motivated greatest is the development, technological development. Yeah, yeah, and oh, okay, goodbye. Thank you very much.
Yeah, sorry, we're extending this a bit, but of course, if anybody needs to leave for whatever reason, please feel free. Otherwise, great, we can carry on the conversation for a bit more.
Yeah. Yeah, so yeah, I'm motivated with the development of the technologies, and yes, and in a daily, research activity, we are working for deep learning and the robotics technologies, and yeah, from the theories to the coding and the applications. The this this topic is really nice for the application of our techniques, and also from the viewpoint of the education for the students, it will be, I believe it is very important for the young people and in Japan to know the situation of this kind of terrible situation with the landmine and all over the world. So from the educationally, it is very good that the students join this project to work in this one. So this is my motivation.
Absolutely, and actually, I think that's a great point to build off. It actually segues to another question I had, which was, how can young people be encouraged to interact more with this kind of disarmament work through their careers? I mean, throughout perhaps your own, sorry about the background noise, but throughout your own experiences working on this project, or even your journey leading up to this project, what various points, I guess, put you in this position, and what kind of opportunities did you see appearing before you to then end up working using the skills that you had from your own careers and professional backgrounds towards a project like this? I think it's a really great for anyone young watching this to be able to kind of project where they could imagine themselves going forward, how the decisions they make now could have this impact in the future, and how they could be making decisions now to have a certain impact in the future. So yeah, just any of your inputs on that would be really interesting. Yeah, Gurkan,
I would like to use this question also as an opportunity to give credits to the also people who worked a lot on this project, to students, interns, so who accepted to work on this project last year before end of March, this March, so for 6 months. Iris, or in here also I put her name, Iris and Huishu from our labs. Also, they were 2 student interns working on both sides, in the AI part, but also in the data harmonization part, so the landmine part, but also data space part. And and they were also very interested in the challenge, as well as the technical part of it, not only the application, which is obviously for the good, but as well as there are also interesting technical challenges here where people can learn, new students can learn more, and then apply also in other areas, not only in the humanitarian domain, could be any domain. For instance, certain AI problems. I have seen also the deep learning applied by Professor Sawada's group. This is applied in many domains right now. So these kind of projects give us also access to some real world data where we can focus on a real problem. And if we can make things work there, that would be a really good indication that we can also achieve other problems. Plus, during this process, we all learn from it, including myself. So we had the chance to learn from this domain.
Yeah, brilliant.
Can I just add on that as well? Because I think, as the 2 other gentlemen nicely put, that it's really important that we have people educating themselves in humanitarian action. But I also think that it does not necessarily has to be, in humanitarian action, because we see that things are so interlinked, and especially maybe humanitarian action is so cross-sectorial that you need input from, like everything else. I myself did a master in disaster risk management a few years ago, and they have, that education haven't even found its boundaries yet. So you can do everything from engineering to social science to health, and it's still needed somewhere. So if you find an interest in mathematics or engineering or AI, there's still going to be use of it in humanitarian action and to solve some of the challenges we have. Yeah, thanks.
Brilliant. No, thank you. And actually, well, building off this as well, and of course, Hideyuki, if you wanted to jump in as well, but just thinking out loud, Gurkan, I was also wondering if NEC, I don't know how much you know about the other companies kind of in this field working on projects like this, but is NEC quite unique in the way that it's taking its skills, it's taking its expertise into this kind of area, or do you know of other firms, other companies, that are using what they have, what they can bring to these kinds of challenges? I was wondering if you had any information on that, but Hideyuki, if you wanted to expand on the role of youth as well. But yeah,
well, in the case of the companies in Japan, I don't think there are a lot. Maybe, as far as I know, NEC is the only company who is working in this kind of activity, I suppose. Do you know, Gurkan-san, about the situation in Japanese companies?
I think there are two maybe in sub questions here. One is the why NEC involved. I think NEC is mainly involved in this social good type of projects. Also humanitarian aid wise, it's not the first project NEC is involved. So there were already ongoing work. So we have also work in this domain now. So it introduced us by NEC, I would say. So for NEC, I'm sure there are also other works in the humanitarian domain. Maybe we could check. And for the other companies, I mentioned NGOs. So I wouldn't define as Japan, Europe, or USA, but there are non-governmental organizations who work along with the governments or other units such as UN units or so for landmine clearance or other related projects. But if you ask me if there are like large IT companies, I also don't think most of them have such projects, because maybe being too focused on certain fields. So it is kind of a new field for such an IT company to focus on, and it is of course a kind of decision to consider if this domain is where they can make an impact. But I think there could be, of course, that would be good to have other private organization also in this field.
Absolutely. So yeah, I had one final question before we move on. Thank you so much for giving up your time for this, but I'd really like to hear from you. What were maybe some of the more unanticipated challenges that you experienced through the course of this project? The ones which you really perhaps surprised you. It's always interesting to hear those things, because I think normally, and I think sharing this kind of information is very important. So yeah, final question.
Maybe I can tell from my side. When I first heard about landmines, I wasn't sure that's such a big deal. But after getting into, I noticed there is actually a community working on this quite some while, and they organize events, and there's really like people work on it, as well as UN and other big organizations. So that was really good to see this type of effort, also not being alone in the field. I would say this is one of the things I was positively surprised working on this project.
Right, brilliant. And if anyone else had any thoughts?
Yeah, for me, before joining this project, I didn't notice the situation of the landmines. I haven't thought about so much landmines and unexplosive objects are still existing. Maybe Japanese people do not think about this kind of situation, because I don't think there are landmines buried in the land of Japan. And these days we notice about the situation of the world these days. And day by day, the number of the landmines are increasing. So I noticed the situation, that it is my motivation it is my pleasure to join this project, to apply my knowledge or our techniques into this kind of automatic detection, the landmines, to clear up one by one.
It's really great to hear. And Martin?
Yeah, no, I have a more administrative surprise, actually, I would say, and that is that I mean, everyone is flying drones all everywhere, and you can easily buy a drone for almost nothing in many places as well. But once it comes to, yeah, and you often hear about also drones being used for delivering medications in less developed countries. You hear about they can deliver food packages. Amazon can deliver a package with a drone, things like that. But what surprised me then was when you try to bring a drone into a less developed countries, they are very hesitant to allow you to do that. Even though I come as a representative of ICRC, who are completely impartial and neutral, they still have there are many authorities which has a fear, maybe not a fear is not the right word, but they are a little bit afraid of having drones flying around, even though it actually benefits the civil society and the authorities as well, because you can help them clear land or find mines and clear land and re-establish land. But that has been a rather big challenge, getting equipment which can save lives into other countries.
Yeah.
And even onto an airplane, actually, commercial airplane. So, and that's why we're also having small drones, because the bigger drones, their batteries produces too much energy, so you're not allowed to bring them on a commercial airplane. That was also like a bit of a surprise to me. That you, so.
Yeah, in fact, drones. The technologies about the drones are developing very fastly. In fact, 5 years ago, the drone could not stably fly, as it is these days. And day by day, that technologies for stable and well-controlled drone flying is getting better. So it will be a very good opportunity to apply the drone and some other associated technologies to support this kind of field, and also bring it to the developing countries. Not only the technologies, but also the price of the drones are. Yes.
Yeah, no, absolutely. Dispelling these ideas of drone as a bad technology and kind of like one that can cause harm, and recognizing its real potential there and its value.
Yes.
So I said that was the last question. Again, I don't want to go on for too long, but I noticed that there is a question in the chat. So if we do have time to maybe just go through that quickly. And I'd also maybe point out here, if at some point, just before we finish, if you feel comfortable with anyone reaching out for you to ask any other questions they may have, if you feel comfortable sharing perhaps an email, that would be great. But otherwise, one final question that we have here is, oftentimes in policy discussions surrounding disarmament and non-proliferation, there is a disconnect in communication between those on the technical side and those in policy. Do you feel there is a similar difficulty in communication between the various actors in this field, i.e. private actors, public academia, etc.? So yeah, this disconnect that you mentioned, Martin, as well in your presentation, is it a similar issue in this field, or does it not have to be? Yeah.
Yes, there's a disconnection. But I think it's often because when academia is trying to develop some kind of tool which can detect, for instance, landmines and explosive remnants of war, they might not be talking to the practitioner. Or maybe the practitioner is not good enough at communicating the needs they have. So often something is invented which is rather large, expensive, and breaks down rather quickly once it's in the field. So I think what we have been doing by discussing it so much and talking about it and trying to use off-the-shelf products, which was already known to work in these places, we have mitigated that. But it's definitely something which happens all the time in mine action, and I think it will continue. But then again, the industry itself also have a hesitation against or a little bit of a hesitation on including new technologies. So it's taken quite some time for the sector to see the purpose of it and to implement it in an operational context. When it comes to the policy part of it, I think also I agree on that a bit, because some of the policies and we have these international mine action standards, which is developed by UN, the UN Mine Action Service, and the Geneva International Center for Humanitarian Demining on different subjects in the landmine sector. And sometimes these international mine action standards also becomes a little bit too extensive in the needs for in an operational context. So basically they can tend to take away resources, a bit of resources away from where it's most needed, and it's still most needed to remove the mines. I'm working, for instance, now on how we can improve climate change adaptation in mine action, and that will be incorporated in an international mine action standard. And you have to be very careful about not putting too many demands on an operational organization who might already struggle with funding in that context. So I think there is a tendency to a bit of diversion on the policy and on the operational side of things as well.
Okay.
Thank
May
you.
I add something to Martin? So I'm not in the policy field really, so I cannot directly answer that this is a situation in the communication and policy makers. But we should know that this is, after all, one of the sensitive area, because it's related to weapons or like old conflict zones. And there might be, by old, we don't mean 100 years old, might be also just recently happening conflicts. For that reason, of course, I would expect some communication might be not easily doable because of sensitiveness of a certain area. For instance, from my side, I was checking with the ChatGPT recently just to ask for a landmine-related question, and directly the answer I got was from the question. I don't remember exactly what I asked about, but was basically, okay, if you have questions about landmine, please contact the local authority so they can give you information. So
Yeah.
even ChatGPT is pretty sensitive in this topic. So that's why I would expect certain communication issue. Yeah.
Right. That's a really interesting barrier there. But yeah, no, I think it's been a really great discussion today, and I'm worried about the time. So I think we might start wrapping it up now. And as I mentioned, if you'd like to share your information, I mean, you sent it through. If it's okay, then yeah, people can reach out to you with any other questions they have, learn a bit more about this really fantastic project. And we really look forward to being kept in the loop about the progress that you made, because it really still is a work in progress, and really looking forward to seeing those results. I don't know, if you wanted to say anything now that you're back, but otherwise, thank you very much from my side.
Yeah,
Thanks
thank you
very
so
much.
much. Yeah, thank you to all the speakers for helping us with this webinar today. I just have a few last words. Stay up to date with Scrap Weapons work. Join our newsletter by writing to scrap.weapons@soas.ac.uk and follow Scrap Weapons on social media. As mentioned before, a video recording of this webinar will be available on Scrap Weapons YouTube channel soon, and the links will be shared about in the chat. Thank you all so much for your participation. That's it from me.
Thank you.
Thank you very much. Have a good rest of your days. Right.
Have a nice day. Bye.
Thank you very much. Bye for now.
Thank you very much. Goodbye. See you.